Hello there. In this video, we will be learning about whether the frictional force is necessary or not. Also, we'll be understanding the ways in which we can increase or decrease the friction. So first let's understand what is the frictional force. So imagine that we have two objects, object number A and object number B. Now the moment object A slides over object number B, there is a relative motion, and if you see from a microscopic level, these two surfaces are irregular, they are rough. And because of this roughness, what happens is these surfaces tend to get interlocked into one another, and that is what results in the frictional force. So the frictional force is a force that opposes the motion of one surface over another. It acts when two surfaces are in contact and try to slide past each other. Now, since the frictional force is the one that opposes the motion, so shouldn't there be no necessity for the frictional force? Let's try to understand with the help of an example. Let's take this example. What do you think? Is it easy to walk on the surface of ice or is it difficult? As you can see in this example, the person is not able to walk properly on ice and thus the person is slipping. So why is the person slipping? Has friction anything to do with this? Let's try to find out. Now the reason the person is slipping on ice is because its smooth surface and a thin layer of water reduces the friction. Now because of this reduction in friction, the person is not able to grip properly on the ground and thus falls. But this again brings us another question: how is friction in the first place helping to walk? Let's understand this with the help of this example. When you are walking, you are actually applying a backward force on the surface of the ground. Now, since you are applying a backward force due to Newton's third law of motion, to every action there's an equal and opposite reaction. So the ground also applies an equal and opposite forward force on your body, and it is because of this particular force that you are able to walk. If there is no friction in the first place, you will not be able to have a grip on the ground, and thus you will be not able to push the ground in the backward direction, and ultimately the ground will not be able to provide you this force that is required for walking. So we can summarize this: friction provides the grip between our feet and the ground, enabling us to push backward on the ground, and in reaction the ground pushes us forward, allowing us to walk. Now with the help of this example, you can clearly see the importance of friction in our day-to-day life. If the friction wasn't there, we would not be able to walk in the first place. Now, there are many other examples in our day-to-day life where friction is really helpful. For an example, applying brakes in a bicycle. When you apply brakes in a bicycle, these rubbers will push against the moving wheel, and thus the friction would be created, and because of this frictional force, the tire will ultimately stop after some time. Similarly, for constructing a house, we need the friction, because if the friction wasn't there, these bricks will never be interlocked into one another. They will keep on slipping over one another, and thus we will never be able to make this structure. Now, another useful example of friction in our day-to-day life is how we are able to write on a piece of paper. It's only because of the frictional force between the paper and the tip of this pen that the pen is able to write on the sheet of paper. Have you ever tried writing on a paper that has oil on it? It's very difficult to write, right? Because what actually happens is oil reduces the friction, and that is the reason we are not able to write properly on that particular paper. So we can conclude that the friction helps bicycle brakes to stop the wheels, keeps the bricks firmly in the place for strong houses, and allows the pen tips to grip on the paper for better writing. So with all these examples, you might be wondering that it's really good to have friction, right? But not always. Let's see another example. This is a brand new tire and this is an old tire. Now you are clearly able to see that the grooves and the threads on the new tire are pretty clear, like you are able to see it's perfectly fine. But as the tire is getting older and older, these grooves are fading away. So this is a negative effect of the frictional force. The friction between the tires and the road causes gradually wearing away of the tire surface, leading to their wear and tear over the time. And this is the reason that we have to replace the tires after certain kilometers. Now let's see another drawback of friction. Now in this simulation, carefully see this particular side where the temperature is being shown. Now the moment I am sliding the chemistry book over the physics book, there would be a friction force created, and because of the friction, just focus on what's happening to the temperature. Now, as I am sliding the chemistry book over the physics book, carefully note what's happening to the temperature. As you are able to see, the temperature is rising. So we can also say that the frictional force also causes the heating, something that could be good and bad depending upon the situation. So like you can see in these two examples, in this particular case, when you rub the matchstick on the matchbox, the sparks get created, and the sparks are ultimately created due to the friction force. Now, in this situation, the friction force is good because it is helping us to ignite the matchstick. But if you see, when a spacecraft is entering the Earth's atmosphere, when a space capsule is entering the Earth's atmosphere, because of the friction created by the Earth's atmosphere, there's a lot of heat created. And at that particular time, this friction is not something desirable, right? Because it is ultimately affecting the structure of our space capsule. Now, the reason the heat is produced is because when two surfaces rub against each other, their microscopic bumps collide and create resistance, converting the mechanical energy into the thermal energy. So now that we have a clear idea that friction in some situations is a necessary force versus in some situations it is not a very desirable force. So let's understand how can we increase and decrease the frictional force. First, let's try to understand the ways in which we can increase the friction. So the very first way in which we can increase the friction is by making the surface rough. Now, if the surfaces are rough, the intermolecular interactions would be more and hence the friction force would be more. Now, the second way is when you press the surfaces harder. For an example, you are pressing this book harder on this particular surface. Now, because of pressing this book harder, the kind of intermolecular interactions would increase and thus the frictional force would increase. The third way is to add the grooves or threads in the tires. As you can see here, the reason we add the grooves and threads in the tires is because it increases the grip on the ground. Because of this increased grip, the friction force is thus increased. So now let's understand the ways in which we can reduce the frictional force. Now the first way is to make the surfaces smooth. Now the moment the surfaces are smooth, the interlocking between these surfaces would be less, and because of the less interlocking, the friction would ultimately reduce. The second way is to use oil or grease, the lubricants between the surfaces. Now, since oil, grease, these lubricants are slippery in nature, now the moment you put these lubricants between these two surfaces, what would happen? They will create a thin layer of slippery surface that would ultimately reduce the friction because then there would be less number of interlocking between these two surfaces. Now, the another way to reduce friction and one of the most interesting ways is to use the wheels or rollers and also to use the ball bearings in the moving parts. Now, how these two are able to reduce the friction, let's understand with the help of an activity. Now, let's say we have this box and I'm moving this particular box. Now, as the box starts to move, there would be a frictional force created over here, and this frictional force will oppose the movement of this particular box. Now, if I try to move this box with the help of this particular spring balance and apply a force in this direction, the reading in the spring balance will give me some idea about the frictional force. More the reading, more will be the frictional force. So like in this case, if I'm moving this box from this position to this position, let's say the reading in the spring balance is about 80. Now let's redo this activity, but in this case, let's say we place the rollers between the box and the ground. Now with the help of these wheels or the rollers, if I'm trying to move this box, it is much easier to move this box because if you are able to see, there is very less frictional force in this situation as compared to the first situation. So we can clearly deduce that with the help of the wheels, rollers, in some situation ball bearings, these all things ultimately help to reduce the friction. Now the reason they are able to reduce the friction is because they change the sliding motion into the rolling motion. In this particular situation, the box was sliding. But now in this particular situation, these wheels are rolling, and rolling friction is lesser than the sliding friction, which creates much less resistance between the surfaces and thus ultimately reduces the friction. I hope you are now clear with the advantages and disadvantages of friction in our day-to-day life, how the friction can be increased or decreased. See you in the next video. Till then, bye-bye.